Okay, so let's go ahead and solve radical equations. And what we want to do is isolate the radicals. So right here, the radical is already isolated. So remember, just like when we did the square root property, what do we need to get rid of a square root? So before, when we had a square, the square root canceled with the square. So it's going to be the same thing but opposite. So to cancel the square root, we want to raise both sides to the second power. So square both sides. The exponent and the square root cancel, and you're left with 2m minus 2 is equal to m minus 1 squared. So to do this, now notice what we have again is just a polynomial equation. And all you need to do is simplify everything, move it over to one side. So 2m minus 2 is m squared minus 2m plus 1. And then bring everything over to the left, negative m squared. If I add 2m to both sides, you get 4m. And then subtract 1 to both sides, you get minus 3. So now remember, when you have a negative in the front of the square, it's not very easy to factor. So let's go ahead and get rid of that by changing the signs. And what I really did here, right, is I divided both sides by negative 1. And then go ahead and factor. So can we factor this? M minus 3 minus 1. So m minus 3, m minus 1 is 0. Again, back to a polynomial equation, right? When you factor it, set each of the factors equal to 0. So m here is equal to 3, and m here is equal to 1. So what we have here are two solutions, but whenever you have a function which has a restricted domain, meaning it's not negative infinity to infinity, you need to plug it back in to check. So if I plug the 3 into this equation, you get the square root of 2 times 3 minus 2 is equal to 3 minus 1. So this is square root of 6 minus 2, which is 4, is equal to 2, and square root of 4 is 2. So this answer over here, m equals 3, that one's okay. So let's go ahead and check the other one, m equals 1. The square root of 2 times 1 minus 2 is equal to 1 minus 1. So this is 2 minus 2, square root of 0 is 0. So again, 0 equals 0. So this solution here is also okay. So make sure that you check your answer at the very end to make sure that it is in the domain of the function that we were talking about. So let's go ahead and do one more problem. Bring everything over to the right-hand side so that we can get rid of we can isolate the square root. So the square root here is 5p plus 11. And in order to bring everything over the other stuff to the right, I just need to add the 1 minus p because notice the parentheses are there. If you want, you can distribute the negative 1 and then do them separately. But what I'm going to do is add 1 plus p to both sides, because those will cancel. Once you have that, square both sides. So the square and the square root cancel. 5p plus 11 is equal to p squared plus 2p plus 1. So if you haven't been doing enough of those, right, that's a perfect square. We can get this fairly fast. And then solve. So I'm going to bring it over on the other side this time, just to show you that you can. If I subtract 5p, you get minus 3p. And then if I subtract 11 to both sides, I get minus 10. So the factors here is going to be p minus 5 times p plus 2 is 0. So here p is equal to 5, p is equal to negative 2. Okay, so let's go ahead and plug in these numbers into the original equation. So we get the square root of 5 times 5 plus 11 minus 1 plus 5. And we want to see if that's 0. So this is the square root of 25 plus 11 minus 6. And this is going to be the square root of 36 or 6. So 6 minus 6 is 0. And this answer over here is okay. So let's go ahead and check the other one by plugging in the negative 2. So the square root of 5 times negative 2 plus 11 minus 1 minus 2. This is going to be the square root of negative 10 plus 11 minus negative 1. So we get on the inside of the square root of 1 plus 1 is 0. And that's not true because the left-hand side is going to be 2, and 2 is not equal to 0. So this one over here, that one is not okay. So our only solution is this one on the left, p equals 5.